All right, let's continue. Number 25 says the function above, where c and d are constants, meaning c and d are numbers, okay? F is differentiable at x equals 2. So this is important because this tells us that the graph is differentiable at x equals 2, and also meaning it's continuous. So if I were to imagine this graph at x equals 2, there's no problem. So cx plus d probably is a line, and then x squared minus cx is probably a graph. And if you look at the entire graph, there's no breaks, no problems. So this is just a sketch of what we imagine this piecewise function is. Okay, so the thing is that x equals 2, we're pros at this. We know that the limit as x approaches 2 from the left of cx plus d is equal to the limit as x approaches 2 from the right of x squared minus cx. So we're going to go ahead and plug in 2 into both equations and make them equal to each other. So let's do that. Okay, so we're going to have c times 2 plus d equals 4 minus c times 2. I got 4 because I did 2 squared. So if I try to simplify this as much as I can, let me get d on its own. I'm going to do subtract 2c, subtract 2c. I'm going to have d equals 4 minus 4c. Now, this is great, but not good enough because there's a d and a letter c in the same equation. That doesn't really help us right now get a specific number. Okay, so we want specific numbers for c and d. So there's another thing that we know about this function. We know that the slope of this side is the same as the slope of this side at x equals 2. All that means is the derivative on the left of 2 and the derivative on the right of 2 are equal. So in other words, the limit as x approaches 2 from the left is equal to the derivative on the right. So let's take the derivative of cx plus d. Remember, cx plus d, c is a number, d is a number. So the derivative of that is c. The derivative of x squared minus cx is 2x minus c. And if that just means I'm going to set them equal to each other because they're equal at 2, and I'm going to plug in 2 over here. So I'm going to get c equals 4 minus c. That's going to be 2c equals 4, c equals 2. So this is helpful because now we know c is 2. We can just plug it in here. So d equals 4 minus 4 times 2, 4 minus 8, d is negative 4. And now the question is to add them up. So I have 2 plus negative 4, which is negative 2. And that is my answer. Okay, number 82 is calculator active, so you're expected to use a calculator for this one, okay? So you have the particle moves along a straight line with a velocity, okay, at time t greater than or equal to 0. Now, what is the acceleration of the particle at time equals 3? So we have to remember PVA in terms of derivatives, okay? So we have to remember this. So to get acceleration at time t equals 3, we need to get the derivative of velocity. So we need to get the derivative of velocity, then plug in 3. Well, the setup of that is v prime of 3. So use your calculators to solve this. Next up. Okay. So we have y equals 2x plus 3 over 3x plus 2. Then we need to get dy over dx. I'm going to let you guys finish this problem, but since you're dividing, you know you need to use the quotient rule. And we know that's low d high minus high d low all over low squared. Where if we break it up, our high is 2x plus 3. Our low is 3x plus 2. The derivative of high is 2. The derivative of low is 3. Okay? So that's sufficient. I know you can put it together and find the match. Number 9, so you have a function, and then you need to get the derivative of it. Then plug in 0. That's what it's asking. So let's do it. We have natural log of x plus 4 plus e to the negative 3x. So it's complicated. I already know it's going to have to be a chain rule, so I'm going to focus first on natural log. The derivative of that is 1 over the entire argument, so it's going to be x plus 4 plus e to the negative 3x times the derivative of the argument inside the parentheses. So derivative of x is 1. The derivative of 4 is nothing, it's 0. The derivative of e to the negative 3x is obviously going to be e to the negative 3x, but we have to multiply it by the derivative of negative 3x, which is negative 3. So if I want to make this nice, I can say, take this whole thing, put it in the numerator. I can have 1 minus 3 e to the negative 3x all over x plus 4 plus e to the negative 3x. Now I'm not done because I need to plug in 0 here. So f prime of 0, I need to solve for it. 1 minus 3 e to the 0, because negative 3 times 0 is 0, over 0 plus 4 plus e to the 0. So e to the 0 is just 1, 1. So 1 minus 3 is negative 2, over 0 plus 4 plus 1 is 5. And this is my answer, A. Number 14, I have a function x squared times sine of 2x, and I need to get dy over dx. So here they're being multiplied, so I know I need to use the product rule. Product rule. Okay, and I'm going to help you split it up. F is x squared, g is sine of 2x. F prime is 2x. G prime is the derivative of sine is cosine of 2x, times we have to get the derivative of 2x, which is 2. So if I simplify that, it's going to be 2 cosine of 2x. Okay, and make sure you put it together properly and simplify to find the match. Okay, so a particle moves along the x-axis so that at time t greater than 0, the position is given by this formula. And it's saying what time t is the particle at rest. Particle at rest means the velocity is equal to 0. Now we know to get from position to velocity, we need to take the derivative. Since this is not a calculator section, we have to take the derivative by hand. No problem, we can do that. So let's take the derivative. 2t to the third power is 6t to the second, minus 21t to the second is 42t, plus 72t is just 72, and the constant has a derivative of 0. So this is my derivative. This is the velocity, if I want to label it. Now, if I want to know when it's at rest, I have to set this equal to 0 and find the time that it equals 0. So I'm faced with this algebra. I need to solve for t. There's common factors. It's 6, so I'm going to take out a 6, divide each term by 6. I have t squared minus 7t plus 12 equals 0. So now I can factor t squared minus 7t plus 12. I know everyone likes to use this setup. Okay, two things that multiply to positive 12. Add to negative 7. All right, so we have t minus 4 times t minus 3. And we have our times. 6 equals 0 means nothing to us. T minus 4 equals 0 means t equals 4. T minus 3 equals 0 means t equals to 3. Great, so our times are 3 and 4. Okay, so 76 is a calculator question. I'll let you answer that. They do give you the velocity, and they want to know what's the acceleration at time equals 4. So I know to get from velocity to acceleration, I need to take the derivative. So I need the derivative velocity evaluated at 4. And just please make note to make sure that your calculator is in radian mode for this exam. Okay, so I printed out the problems from the review packet that applies to derivatives that we're reviewing right now. So number 2, they give you the function, they want to know the derivative, and then to plug in 2. Okay? So we know we need to use the product rule here because we're multiplying 2 functions, e to the 2x and x to the third plus 1. Make sure to plug in 2 in the end. Number 13, it's the same. They want you to get the derivative. However, you need to get the third derivative here. I want you to get the third derivative, okay? So I have y equals cosine of x minus natural log of 2x. Y prime is the first derivative, so that's negative cosine of x minus 1 over 2x times the derivative of 2x is 2. So that's negative cosine of x minus 1 over x. Okay, so that's my first derivative. If I don't like 1 over x, I can change that to negative cosine x minus x to the negative 1. Okay, so this is the first derivative. You need to get the second, and then you need to get the third derivative. You can do it. Find the match. The reason why I put number 17 here is, although this is for differential equations, okay, you can do it because you know how to get the derivative of functions. So what you need to do is look at y. You need to get y prime and y double prime, and you need to see whether it fits A, B, C, or D. Okay? So y prime here is going to be 3e to 3x minus 5. Make sure you know where I'm getting that. And double prime is 9e to 3x. Okay? So let's say I'm checking it for A. That means I'm plugging in 9e to the 3x for y double prime, so I'm going to do that. 9e to 3x minus, and I'm plugging in y prime, which is 3e to 3x minus 5, minus 15. And I need to see if it equals 0. I need to see if this is a true statement. So let me go ahead and distribute 9e to 3x minus 9e to 3x plus 15 minus 15. Well, that works. So that is, okay, lucky for us, fortunately, that's the answer. For number 19, the reason why I put it here is because it looks like it's a limit problem, but if you remember, this setup that you're looking at right now is the definition of derivative. Meaning, this is a hint that what they need you to do is focus on the function x to the 20th minus 3x, and they want you to get the derivative of it and plug in the value of e. You can do that. You can get the derivative of x to the 20 minus 3x and substitute e for x. All right, number 21. They give you a table of values. We haven't done this in a while, but you can do this, okay? They give you h of x as f of g of x, and they want to know what's the h prime of 1. You need to get the derivative, so you need to do the chain rule, okay? So that means the derivative of f, leave the inside parentheses alone, times the derivative of g prime of x. Okay, that's the derivative. Now simply plug in 1, f prime g of 1 times g prime of 1. Find the values. Okay, let's start with g prime of 1, g prime 1, negative 2. Times, what's g of 1? G of 1 is 3. F prime of 3 is 7, so this becomes 7 times negative 2, which is negative 14. Okay, so for number 81, you're given the derivative, and they want you to find the original graph. So this is just the other way around, okay? So let's try the first problem. Let's try A. Okay, so if I'm looking at A, I'm increasing over here, so that has to be a positive. Okay. I'm increasing over here, so that's also a positive. Then I have a 0 here. Then I have a negative because I'm decreasing. So let's see if it matches. Do I have a positive here? Okay, it does match. Do I have a 0 here at 1? Yes, it matches. Is it positive before 1 like I said it is? Yes, it is. Is it negative? Yes, it is. So lucky for us, that's the answer. Okay, you can try the other problems like B. B is decreasing, so that means this is a negative derivative. Well, if you look at the first part of our graph of f prime, it's positive, so this already doesn't work. Same reason for C. For D, it is positive, I agree. But then suddenly, this is all negative. All of them is negative. Well, this is not all negative. A part of it is positive, and a part of it is negative. So D doesn't work. Okay, for 86, you have the velocity, and they want to know if the particle is moving to the left, moving to the right, or is the acceleration positive or negative, okay? So just a few reminders, if the velocity is positive, then you're moving to the right. If it's negative, then you're moving to the left. So plug in 1 into the velocity and see if it's positive or negative. Then for acceleration, just try v prime of 1, okay, because that gives you acceleration, and see whether that's a positive acceleration or negative acceleration. You can do it. Okay, so a tire is leaking air. It has an initial pressure of 30 pounds per square inch, which is PSI, so 30 PSI. Okay, so the function t is the amount of time in hours, so t is hours. Okay, so what's f prime of p? That's just saying if t is f of p, t prime is f prime of p. So this is originally just hours it takes. Now if we get the derivative, that's going to be hours per PSI. It's right here. Okay, for this one, they give you the derivative. They want to know where it's increasing. Just a hint, increasing means the derivative is positive. That means that you need to graph this and find where it's positive, okay? And if you do it correctly, you should get that it's positive everywhere from negative infinity to infinity. Okay, go ahead and try the closing question and make sure that you get a check to make sure that you're on the right track. Good work, scholars.